Okay, welcome back. So this is the second video in the introduction to full stack and sort of multi-tier development module in C# application development. So what we're going to do in this video is we're going to talk about MVVM and MVC for two reasons. One, MVVM kind of motivates code and behavior decentralization, which is going to become kind of a theme for the rest of the semester. And MVC is a really popular design pattern for web applications, which is going to be the bulk of what we do for the rest of the semester. So previously what we've done is we've looked at MVVM as a design pattern that's commonly associated with WPF applications. And we talked about how you don't necessarily have to have MVVM to build a WPF application, but it makes things a little bit nicer. And so most of the time when you see best practices for WPF application development, those best practices are they come from a point of view of MVVM being the design methodology of choice. So what we're going to do in this video is we're going to take a step back and we're going to look at MVVM as a sort of thing that is motivated deeply by maintenance more than anything. Why would somebody choose something much more complicated like MVVM versus just simply updating labels using named label controls in WPF? Which is actually a question that people have asked quite a bit this week as they're trying to work on the calculator. So the idea fundamentally of MVVM is that you can basically take all of the software components, so all of the source code artifacts in your application, and you can put them into one of three bins. And so those bins are models, which are solely capable of storing state. And these things usually map one-to-one with records in a database. And so if you're familiar with ORM, these models are the result of mapping a relational database table, so a record in that table, to a class structure. So these models are really about state, they're not about behavior. Views are actually the controls. So this is what actually gives the user the ability to interact with this state. So views contain things like windows that have buttons and text boxes and all this kind of stuff to gather data, but also to select data and manipulate the state of that data. And then between models and views, you have this concept of a view model, which is the intermediary between the two. And this is where the behavior exists for the application. So if you think about what a model is just a record inside of a database table. That record inside of a database table itself doesn't necessarily have all that much behavior. But once you convert it into a model, you might be interested in putting all of the functional members on the class that is the model. This design pattern really wants you to put all of that stuff on the view model. And the reason is that users are going to interact with that behavior through the view. And so what's going to end up happening is you're going to have properties that have commands, things like delete or things like edit. Those are going to be triggered and bound to click handlers or bound to whatever events you want on the UI through a view model and not the model. What this does is it minimizes the size of the models, which is important because if you think about the previous video, these models typically live on an application server or they are straight from the database server. And so if you have all of the behavior and all of the properties on the model, you're going to spend a lot more time and resources trying to transfer all of that data from the database server to the application server over to the person who's actually clicking the button or selecting something from the list view. So fundamentally, we don't actually really care about the behavior of a record in a database. And actually, there's no concept of behavior of a record. Really, the behavior in a database is at the database level. You can update, you can delete, you can insert into tables, but there is not custom behavior on a database table. At the same time, we don't actually care about all of the display values for the model in the database. Like we said last time, you don't necessarily have to store the string formatted values of a price if you already have the decimal price that's going to actually be used to make calculations and things like that. So what we're doing is we are separating the pieces of the model or of the object into areas to maximize performance. And so this is fundamentally different from the sort of object-oriented paradigm that you might be familiar with when you're stuck on one machine. What we care about is if you have a bank account, that bank account could have many different facets. And so there could be many view models associated with the bank account model, and there could be many DTOs associated with the bank account model. And what you're trying to do is use the least amount of data and the least amount of behavior that you can to maximize the efficiency of data transfer between our furthest away server, the database or the application server, to the local machine that the user is actually using. So the least amount of data that you can hold around, the least amount of behavior that you can cart around with your classes, the better off you're going to be in terms of performance, but also it's going to be less code to maintain, and your entire sort of application is going to be much more stable. So why does this matter? Well, we've talked a little bit about minimizing the data to transfer from the database to the client, but it actually is also more important to pull all of the behavior away from the UI as much as possible. And in fact, if you look at the sort of purest definition of what MVVM for specifically WPF is, in those cases, they only want you to have 2 lines of code for each of your code behind CS files for a window. Those 2 lines of code should be the initialize component call that actually sets up all of the event handlers for the window, and the call that actually creates the data context link. So you can set the data context to be the view model, and you can set up the window, and that's it. So in the purest definition, you don't even have click handlers. What you have is you bind the click events or the mouse over events or whatever events you want to routed commands on the view model. And so then all of the business logic and all of the everything is encapsulated in the view model instead of the view. And you can very easily update the view, you can change the view, you can modify the view entirely. And the view model itself does not change at all. So the markup of the view, the outline, the layout, the technologies behind the view, the controls could change, all of that could change, and the business logic is completely agnostic to all of that stuff. This is the biggest reason why you want to use something like MVVM instead of doing all of this state management in the code behind. So what this is doing is this is marching toward what I referred to last video as a headless service. What you want is you want to consolidate your business logic and you want to consolidate your persisted data away from your view so that the view can be replaced with a web application, it can be replaced with a WPF app, it can be replaced with a website, it doesn't really matter. The thin client is the easiest thing to fix. If you've got really solid business logic, that is the cash cow of the application. You can always port that to a new UI. So if you think about the alternative to MVVM, so if you take it to the absolute extreme, we talked about how each of the actual controls in a WPF application has a name attribute or property. You can set that name attribute and you can reference the control, or you can have access to the control from the code behind using that name. And we did an example of that with the priority combo box in the help desk application. So the alternative is, instead of trying to bind to properties, what we would actually do is on each of the events, we would update the content of all of the text boxes, or you would update labels, we would update whatever we need. in the code behind by referring to the name of the control. And there are tons of reasons why you might not want to do that, and most of them are philosophical, many of them are borderline religious, but at the end of the day, what you are doing if you take that approach is you are decentralizing state management, which means that if I have a text box that's going to be updated by a button click, instead of binding to a property that is modified by the button click handler, I'm going to actually tie the contents of the text box, so the text box itself, to the state in the code behind. But if I modify and I add a new button, or if I add a different button and both of those buttons have to modify the state, what I'm doing is I'm adding additional places where I have to go back in and actually maintain the link between the control and the UI and the code behind. And as I add my 15th button and as I create a brand new window that uses the exact same view model, but I have to build this whole infrastructure in my code behind, I am minimizing the amount of reuse and I am maximizing the amount of effort that I have to do to maintain the link that manages state. So this is the easiest way to start a WPF application. If you're very confused about MVVM, you can certainly hack together a calculator application by simply modifying the text box content property in the code behind. But if you're trying to build scalable software that you're going to be maintaining for potentially 10 years, you don't necessarily want to have decentralized state management. Because if you are coming into the code as a completely new employee, for example, you're not going to know all of the links between each of the labels or each of the text boxes and the particular events that modify those UI components. It's way easier to deal with properties than it is events that drive those changes. So a very common alternative pattern to MVVM is called MVC, and this stands for Model View Controller. If you have seen anything about web application development in the .NET environment in your life, you have actually seen MVC. So ASP.NET MVC is an extremely popular way of dealing with web application development. It's been around for a very, very, very long time. And this is actually the pattern that we're going to start seeing next week. So client-side development of a web application that uses web services is very often done with something like MVC. So the components of MVC are models, which manage data, again, so these are very similar to the models in MVVM, but you also have views and controllers. So views are the things that actually present the data. The difference here between MVC and MVVM is that the view in MVC is literally just the view. It's the kind of read-only state of what the current state of the model is. Controllers are what actually allow you to modify the data. So strictly speaking, if you go through and you click a button to increment a counter or something like that, you are actually using the controller to update the model, and then you are viewing the change to that model. That's all a little bit theoretical, but we're actually going to see how this differs from MVVM concretely next week when we start looking at Angular. So the thing to think about in terms of sort of high-level comparisons of MVVM and MVC is that MVVM is much more focused on the interaction with data than the position of the user to the data. So MVVM is very sort of regimented on this is data that is persisted in a database, this is data that you're seeing through the UI, and here are all the layers that connect those two things. MVVM is much more about your interaction with data from a client-side perspective. It has much less to do with the server side or the persistence components. So the thing about design patterns is that there are a tremendous number of them. And actually, when I took a job 2 years ago or 3 years ago now at the state. And when I took that job, a friend of mine gave me a book on design patterns. It's approximately 700 pages long. And by the time I read maybe the first 100 or the first 125 of those pages, it was basically outdated. Somebody had come up with some grand new library or some grand new way of living life. And so what I want to be very clear about is in the time that we have been talking, about 15 minutes, somebody has come up with a new way of designing software. So design patterns are extremely sort of dynamic, and what you want to focus on is less the purity of your design implementation, but what you're actually trying to accomplish. And so if you think about what I was talking about last week, where I broke MVVM to set the selected value of the combo box, it's really because the amount of effort that it would take to build a data template to achieve what I needed to achieve in pure MVVM doesn't really pay for itself. That's a lot of investment that you don't really get a return on. And so what I want to be clear about is design patterns are great. They absolutely serve a purpose. There are people who take these to kind of religious places that they may not be reasonable. And so what you need to be cognizant of is that you can definitely maybe 80 or 85 or 90% use MVVM and get a lot of the payoff of using MVVM with some caveats that may save you some time or may allow you to be a bit more efficient with your development. So ultimately, design patterns themselves are there to optimize something. And we're going to talk about three really important aspects of software engineering or software design. And ultimately, these design patterns are really there to minimize technical debt. So somebody somewhere has seen a project fail or nearly fail because of something, and that something often is the necessity that invents the new design pattern. And so we might actually choose to do full MVVM, or we might use MVVM but also have event handlers like we had last week, and that's totally fine. You don't have to have a sort of rigid 100% buy-in in order to get something reasonable out of implementing a design pattern. So the three kind of pillars of design that we want to talk about before we go into next week and actually start writing client-side code is we want to always build apps that are scalable, they are as simple as possible, and they are performant. And all three of those things, they don't necessarily add up to 100%, right? You can certainly have a very scalable, very simple, and very performant application. And what will change is the amount of effort that you have to expend and the amount of time that you have to spend to build an extremely scalable project and the application that you're working on. So if the application doesn't need to be scalable, potentially you can pull back a little bit on the scalability. You can cut some corners if you need to. If it needs to be extremely scalable, then you can then potentially make it less performant by spending more effort trying to make a scalable application. So we're going to talk about what these three things mean and why they're important. So you can choose to use the existing design patterns. You can actually we're going to talk at some point in the semester about coding patterns, which are very similar to design patterns. And you can look at a whole, like I said, tomes of these things. And you can find one that will optimize scalability, simplicity, and performance to some extent to serve your needs. But at the end of the day, you can mix and match these things to the point that you can build your own design pattern that really allows you to do optimization to whatever degree you need for whatever kind of application you're trying to build. So if you're talking about applications that are scalable, scalable applications are really focused on two different types of scalability. The first one is adding functionality. So this would be something like maybe Salesforce.com or something like that, where they have Force.com, which is really like this underlying framework. And then on top of that framework, they have tons and tons and tons of pieces that allow you to do various things. So FSU could use Salesforce.com, very large law firms could use Salesforce.com, software companies use Salesforce.com to do client-side portals all the time. And so this is a very scalable piece of software. They can add as many modules, as many features as they want to it, and it usually can support whatever those features are. The other type of scalability is adding users, and my favorite kind of anecdote about this, it always comes back to Pokemon Go, right? So they had an idea for an app. Most of you, if not all of you, will know exactly what that app does. And their initial implementation required essentially graph covering or some variation of that problem. And so what they ended up finding is that they were able to have this very rich, sort of fully featured experience, but when they added maybe the 1,000th or the 2,000th or the 5,000th or the 10,000th person, the server could not handle the load of performing all the calculations that were required in order to find the nearest encounter. So that's the kind of scalability that we're talking about here. As you add users and as your usage ramps up, you want your application to stay up. You don't want the application to fall over simply because you added the 107th person. So this is something that we're going to talk about in a recitation lecture after we have talked about the sort of multi-tiered application we're going to build, and this is a thing that something like AWS or Azure will help you with, but you certainly want to think about these kind of things as you're building your application. If you're doing something like performing some sort of algorithm that is going to have issues with time complexity as you add more and more and more users, or your N goes up, you're going to want to be cognizant of that and kind of prepare accordingly. Simple applications prioritize your ability to contribute to the application, and they minimize the misunderstanding of developers and users. So these are applications that are closer to something like a very cheap game on the iOS store. These are very small tech startups, things like that. They want to simplify their applications, not to reduce their functionality, but to reduce the complexity in the functionality's implementation. And so their goal is to be able to go to a university and find a junior developer and have that junior developer ramp up and get to the point that they can actually make meaningful contributions to the software in the smallest amount of time physically possible. And so this last point is really, really important because it is a concrete example of why something like MVVM is really important. If you don't use MVVM, your simple application can become an extremely complex application but have the same feature set. You could have the exact same calculator app, but instead of having some properties that are bound to a view model, you will have potentially hundreds of lines of code that update a UI element on various button clicks. And that's clearly not necessarily the greatest situation if you're a brand new developer coming into a company. And so lastly, we want to talk about performance and performant applications, and these applications really focus on two things as well. They want to minimize the time between a user making an action on the application and the application responding or reacting to that action, and they also want to minimize the system requirements of their applications. So one of the major limitations of WPF is that WPF is very, very resource intensive, and so there are production WPF applications out there that require gigabytes of RAM in order to run, and that's clearly not the best situation for anyone. If you have an application with really high system requirements, that's going to cut the market down, and you're not going to have as large of a market to sell into as if you had a browser-based UI that doesn't have a whole bunch of system requirements. So performance can come in two flavors, and you've probably seen this in an algorithms class. You can have speed, which is the sort of time it takes the application to react to the fact that you're trying to use it. You can also have space. So this is something like an iPhone app that drains all of your battery, or the iPhone app that takes up so much storage you can't actually have other apps on your phone at the same time. Both of these are important. They're just important contextually. So there could be applications that don't really care about the footprint of the application so much. They care deeply about the speed, or vice versa, or you could have situations where both are really, really important. So before I go, I want to talk a little bit about generic programming as a general concept, and this is something that we're also going to talk about through the end of the semester, kind of picking up after persistence. Code reuse is a thing that is hammered into your psyche from the very beginning, sort of introduction to programming classes. So when you think about when you were introduced to functions in C++, one of the reasons why functions are so important is you didn't have to copy and paste code all over the place. This is an idea that goes far beyond functions. And so you also may have seen things like class templates in C++ that allow you to do much more generic programming. And what we're going to do is we're going to talk about generic programming in C# specifically, using generics and also using dynamic data spaces. But in general, what you want is a software design that is extremely horizontal, so that you can handle as many different scenarios as possible. If you think about the programming assignment that many of you are working on right now for the calculator, you could certainly have click handlers that set a value for each of the numbers on the button. You could certainly, or on the calculator, and you could have a click handler on the plus button that just has a plus addition operator behind it. But you could also have a single click event that is handled by each of the buttons, and then that button could pass its content to that handler. It could also have one central function that then performs all of the operations regardless of what operation button you choose. So there are tons of different ways to implement even something as simple as a calculator. So when you're trying to build scalable software solutions, what you want is you want to be as generic as physically possible. And the reason is because you can always take a generic algorithm and apply it to many different areas or many different applications, rather than being stuck in one application and having to reinvent the wheel all over the place. One of the things that we're going to talk about at the very end of the class is called code automation. And so what we're actually going to do is we're going to take generic concepts, and we're going to generate an entire service layer, so an entire sort of web API stack with T4 templating. And the reason that we can do that is because you can have these sort of generic approaches to problems that basically allow you to just stub in names of models. You don't necessarily have to build code for a brand new service. You can have the new service generated based solely on the properties of the model that you've created for a new piece of functionality. So we're going to talk specifically about generic programming at the end of the class, and we're going to do that in the context of code generation. But it's really, really important to think about these things in terms of design patterns and in terms of how you want to implement code, because as we try to take all of this business logic from something like a WPF app and push it down into services that can be reused over and over and over again, thinking generically is going to be a really, really important part of being successful in doing that. So in the next video, what we're going to do is we're going to do a really quick code along where I show you how you can add multiple projects or multiple different types of projects to a solution, and kind of segment your code to build multiple assemblies and multiple different types of code in the same solution, so that we can prepare for actually building our ABET application we're going to build. So I will see you in that video. Thanks for tuning in, and please let me know if you have any questions via email. Thanks.